Okay, 2.2, limits involving infinity. So the line x equals a is a vertical asymptote of the graph of a function y equals f of x if either the limit of f of x as x approaches a from the positive side is equal to positive infinity or negative infinity, or the limit of f of x as x approaches a from the negative side is equal to positive infinity or negative infinity. Okay, so hopefully by now you guys have a good understanding of vertical asymptotes from your previous math classes. Add this to your notes. Okay, so for example, find the vertical asymptotes of the function 1 over x squared. Describe the behavior to the left and right of each vertical asymptote. Okay, so hopefully by now you guys know that the denominator cannot be 0, x cannot be 0, therefore at x equals 0 you guys have a vertical asymptote. And the graph looks something like that. Okay, so the limit as x approaches 0 from the negative side of 1 over x squared, well, we can see that it's growing, and it keeps on growing. Okay, it'll keep on growing, and it's actually going to positive infinity. Okay, the limit as x approaches 0 from the positive side of this function f of x is equal to 1 over x squared. Again, it's growing. So that's also positive infinity. Okay, but how would we do it without the graph? So, in other words, what we're doing here is we're looking for the limit as x approaches 0 from the negative side. Okay, because that's what this means. Describe the behavior to the left. So, from the negative side. Well, you got to ask yourselves, values that are, so x values that are approaching 0 from the left side, well, in a number line, and this goes out from negative infinity to positive infinity. Okay, we're approaching 0 from the left side, from the negative side. We're talking about values like -2, -1, -1/2, -1/4, and so on. Okay, so we're talking about values that are less than, x values that are less than 0. Okay, so we know that when we do direct substitution here, we get 1 over 0 squared, which is 1 over 0. Vertical asymptote, this is undefined. Okay, so what I'm going to do is, I know that we have a vertical asymptote because my result was 1 over 0, but now I want to know, is this going to positive infinity or negative infinity? So you would pick a test value that's slightly to the left of 0. So for example, negative 1/2. Okay, so this comes out to 1 over positive 1/2. Okay, because the outcome was positive, this implies that my function goes to positive infinity. Had this come out to negative 1 over 0.5, then my function would go to negative infinity. Okay? Now it says, also describe the behavior to the right of each vertical asymptote. Okay? So, very similar now that if x approaches 0 from the negative is approaching from the left, x approaches 0 from the positive side is what we're talking about when I'm talking about the behavior to the right. Okay? So, okay, so I'm going to take a look at this number line again. Now, if I'm approaching 0 from the positive side, I'm approaching 0 from 2, 1.5, 1, 1/2. Okay, I'm approaching it from the right side. Therefore, I'm talking about x values that are greater than 0. In this case, you might want to try a 1/2, positive 1/2. Okay, and remember, keep the idea of the limit in mind. So we are talking about values close to 0. So the closer the better. So technically, positive 0.25 would probably work best here, would be a better guess or a better x value to plug in. Negative 0.25 probably would be a better x value to plug in. The closer the better. So we see that this also comes out to positive. Now the value is positive 1 over 0.5. I could really care less about this. I could really care less about this. It was the sign, because it's positive, I know that we go to positive infinity. We're approaching positive infinity. Okay? Let's look at that one. So same thing. Let's check. Well, I know I have a vertical asymptote. At x equals 1. Because when x is 1, we get the denominator of 0. Okay? So same, we want to ask ourselves, we want to describe the behavior to the left and the right of each vertical asymptote. So let's check it from the left. Okay, just like in that last example, we want to check values that are less than 1 when we're approaching 1 from the left. So for example, let's try 0.5. Okay. So we get 1 over negative 0.5, which happens to be Okay, so it's the sign. The sign is what matters. Okay, this implies that we go to negative infinity. Same thing with finding the limit of 1 over x minus 1 as x approaches 1 from the positive side. Once again, we know that this has a vertical asymptote when x equals 1. Now we just want to check, does it go to positive infinity or negative infinity? So pick values that are greater than 1. So this one you might want to pick positive 1.5. Okay, so we get a positive sign. This implies that we go to positive infinity. Okay, so as x approaches 1 from the negative side, this function goes to negative infinity. However, when x approaches 1 from the positive side, this function approaches positive infinity. And we can confirm it. That's not the graph. With the graph here. Okay, as x approaches 1 from the positive side, we're going to positive infinity. However, when x approaches 1 from the negative side, it goes to negative infinity. Okay. Add this to your notes. Most rational functions have vertical asymptotes at values which cause the denominator to equal 0. If f of x approaches infinity or f of x approaches negative infinity as x approaches a from the right or left, then x equals a is a vertical asymptote. Pretty much reworded what you just wrote at the beginning of the video. Okay. Why don't you guys pause it, try this one. Okay. This is from page 76, number 13 from your homework. X approaches 2 from the positive side. Are values that are greater than 2. So you might want to try 2.5 here. And we can see that because it came out positive, this goes to positive infinity. Okay, now I skipped something very important that I've been enforcing you guys to do. I said the first thing you should do is you should try direct substitution. I should have done that first. Okay, but I knew that this was going to be undefined. I know we have a vertical asymptote when x equals 2, but you guys should get in the habit of, before even doing this, you should have directly substituted the 2. Now the superscript of positive 2 plays no role in here. Okay, when you do direct substitution, you directly substitute a 2, so you get 1 over 0. Now 1 over 0 means we have a vertical asymptote. Okay, kind of like 0 over 0 is in determinate form. When you get 1 over 0, you know you have a vertical asymptote. Now you got to check and see, does my function go to positive infinity or negative infinity? So that should have been the indicator that you should try to see, where does my function approach positive infinity or negative infinity. Okay, I'll do the next problem in the next video. I ran out of time.